Outliers are the second failure mode. In this scatter, one extreme point sits far from the rest, and it drags Pearson's correlation from -0.862 without it to -0.455 with it, nearly halving the apparent strength. Watch for this with data entry errors, an extra zero, with genuine extremes that dominate a result, and with ordinal ratings where Pearson is questionable anyway. Spearman's rank correlation is the standard remedy. Replace each value by its rank, one for the smallest through n for the largest, with ties sharing an average rank, and then apply Pearson's formula to the ranks. Why does this help? Because the largest observation receives rank n, whether it is twice the runner-up or 100 times it. Extreme values lose their extreme deviations. The outliers are tamed. The formula looks elaborate, but notice what it is. Exactly Pearson's expression, with ranks in place of raw values and the average rank in place of the means. Nothing else changes, and like Pearson, it ranges from -1 to +1, with a perfect monotone relationship giving exactly plus or -1. Three differences matter. Spearman measures monotonic relationships, not only linear ones. It is robust to outliers, which receive only slightly higher ranks. And it is appropriate for ordinal data, such as satisfaction scales. For the apartments, Spearman gives 0.14 against Pearson's 0.27. A few large, expensive sales inflate Pearson, and after ranking, they lose most of that influence. This figure shows the reverse situation. The relationship curves upward steeply, monotone but far from a straight line. Spearman is near 1, about 0.975, capturing the strong monotone rise. Pearson is smaller, about 0.88, because it penalizes the curvature. The takeaway sits at the bottom. Spearman measures any monotone relationship, Pearson only its linear part. And back to the outlier scatter for the comparison that seals it. Without the outlier, the two coefficients agree, both near -0.86. Add the single point, and Pearson collapses to -0.455 while Spearman barely moves, -0.813. One observation hardly changes the ranks, so the rank correlation stays stable. In R, the computation is 2 steps. Rank both variables, then correlate the ranks. The manual version applies the ordinary correlation function to the 2 rank columns. The built-in shortcut simply asks for the Spearman method directly. Both give about 0.14 for the apartment data. Pandas does the same in 2 moves. The rank method with average ties, then the correlation method, either Pearson applied to the ranks or Spearman requested directly on the raw columns. Again, about 0.14. Once you see that Spearman is just Pearson on ranks, both implementations become obvious. This decision table is worth a moment. Linear relationship with no outliers, Pearson, though Spearman also works. Non-linear but monotonic, Spearman. Outliers present, Spearman is robust and preferred. Ordinal ratings, Spearman, because Pearson is not appropriate there. And the advice at the bottom outranks the table. Always start with a scatter plot, and if the picture looks linear and clean, use Pearson. Otherwise, report Spearman as well.